Good morning, everyone. This is Dynamics of Mechanical System, practical number 3. Practical is governance. So, in this experimental objective is to determine the relationship between the governor speed and the ball radius, and we have to compare the experimental and theoretical results of the governor, right? And in here you can see governor is a device that automatically maintains the rotary speed of an engine. And in this practical we are going to use 3 different type of governors to check the experimental and theoretical value, right? And here you can see there are 2 different type of governors, right? Porter governor and the Prohl governor, right? And both look like similar, but the fly weight or that ball, you can see for the Prohl governor there is extension of lower arm, right? That is the main difference between these 2 type of governors. In here, while checking that experimental and theoretical results of every type of governors, we are able to understand that different functions, and also understand that advantages, disadvantages of different type of governors. This is third type of governor which we are going to demonstrate, and this call it as Hartnell governor. And it is the different of this type of governor is you can see there is a spring, right? It will controlled by the spring. That is the main difference of this governor. And here by the spring we will give some force, right? And for that other 2 type of governors we have to add some weights, right? When we are doing the practical you will understand better, right? Okay, this is apparatus which we are going to use to analyze the function of different type of governors. In here you can see there's a control panel, right? Below that glass box, and that control panel have on off switches, right? And speed control and display, right? To measure that or show that RPM of the governor, and emergency switch, right? Here you can see this is the port which we are going to fix the governor, and it will rotate, right? This port will rotate, right? When we fix that governor it will rotate, so that we had by using control box we can rotate in different speed, right? Here you can see that this is your lab sheet, and these are the 3 type of governors which we are going to use here, right? These 3 are already explained. So this is Porter governor, you can see, right? Here there's no extension of lower links, right? Same as the dispatch you can see, right? And here you can see, right, that the flyweight or that the ball, right, has some extension, right, from that lower link, right? That you can see, right? That is the difference, right? And the other one is Cardinal governor, right? We all know, right? I already explained this is in here the difference is the spring control, right? Because for other two type of governors we will put some weight, right? Here we will apply force using spring. By rotating spring we will give some force, right? So for this porter and pro governor we have to add force, right? Not force, we have to add weight, right? Here you can see this is how we are going to add weight, right? So that without weight and adding by one weight we will analyze, right? So in here we will add weight in this spindle, right, of that governor, right? If we add more weight, that means we have to rotate it in high speed to move that fly weight upward, right? But in here for that hardener governor we will give force using spring, right? We know that pitch length, so if we know that spring constant and anything and those things, we can measure that force that we are playing. And now I will explain how we are going to assemble this or fix this governor with that apparator, right? Here you can see, right? In here we have to place the governor like this, and there's a two nut and bolt, right? Two bolts, so we can by using board we will fix that governor with that mount, right? Or that base of that shaft, or we can call it as base of that shaft, right? After fixing that, when we give some speed, you can see that governor head will be move upward, right? Because of that you know that head, this is a governor head that will move upward, right? When we rotate it, right, like this, you can understand, I think, right? According to the speed, right? When the speed is increasing, you can see that head will be move upward little bit, right? Like that. And also to measure that movement of upward movement of that governor head, we will use dial gauge, and you can see this on top of that glass there's a hole, right? Through that glass we will put dial gauge, and we can take the measurement of dial gauge, right, according to the speed, right? To start this apparator we have to first we have to make it zero. Speed controller should be in the zero position, and before start the machine or the motor we have to release this emergency switch. Then we have to press that start button, and by rotating that speed control we can apply some rotational speed. By looking this display we can measure the speed of rotation, right? Right now it is 80 rpm, right? So you can see the governor is rotating at 80 rpm, and when we increase this rpm, at some point that governor head will be move upward, right? So that we have to increase the RPM little bit, right? So for this practical, this is now no weight, right? We have had no weight here, so we will increase the RPM and take that linear movement of that governor head, right? Now you can see this is governor head, right? It is in lower position, right? It doesn't move outward now because the speed is not enough. Now you can see when if we increase further, it is moving upward. The head is moving upward, right? Now it is the governor head is in the highest position, right? This is how we are going to do this experiment, and when we decrease the RPM, it will came to that initial position, right? So now it have no weight, right? Likewise, we have to do this experiment for no weight and weight 1 2 3 4, right? Likewise, now we will add some weight, right? For example, in here we have added 3 weights, right? You can see that's mean now that to move that governor head upward, we have to rotate high speed, right, than previous situation, right? So let's see, right? We will increase the RPM slightly and see whether when it move upward, right? You can see now it is 170 RPM around, right? But it is in the lower position, right? Still because of that weight, right, we have added. So we will increase further and see, right? And yeah, if we increase continuously, it will move upward, right? Now you can see it is moving upward, right, little bit according to the speed. So according to the speed, there is a height in the height for that governor head, right? That can measure using guide gauge, right? That is what we are going to do in this practical. Okay. Likewise, for different speed, we will get different readings in that dial gauge, right? Because according to the speed, there will be a movement, right, in that governor head, right? You can see here, right? Like this, by changing the speed, rotational speed, we will measure the dial gauge reading, right? Then we have to plot the graph to understand the function of that governor, right? So likewise, we have to repeat this for these 3 type of governor, right? Okay, this is the end of this practical. This is observation data, right? There are three different type of governors we are looking here. So we have to know the theoretical and experimental data for each type of governor, right? So this is the theoretical data for the Porter governor, right? And here you can see RPM and the sleeve weight for 1 and no weight and 2, right? Just you have to draw for the 3 type of weight difference, right? No weight and 1 and 2, right? Then x-axis should be RPM and y-axis should be displacement, right? And this is experimental data for the Porter governor, same governor, right? In here you can see RPM and displacement is changing with the weight, right? No weight and 1 weight, 2 weight. So this in this plot you have to draw theoretical value and experiment value, right? Compare in same graph sheet for one governor, right? If it is Porter governor, then you will get 3 lines for experimental results and 3 lines for theoretical results, right? In the same sheet, right? You have to draw it in different colors, right? And same as that, you have to plot the graph for other Prowl governor and the Hardnell governor, right? Here you can get the data, right? Observation data for every governors, theoretical and experimental data for every type of governors, right? And this is theoretical value for the Prowl governor, right? And this is experimental value for the Prowl governor, right? You can see here, right? It is for 0 weight and 1 weight and 2 weight, right? And this is for the Hardnell governor, right? The third type of governor which we are looking here. But in here we are not going to add weight or something. We already see that there is a spring, right? By using spring we will get we will give force, right? Therefore there is a 2 different type that adjustment length, right? 4 millimeter and 8 millimeter. So you will get 2 different line, right? This is theoretical data which we are looking here, and same as that Porter governor and Prowl governor. In here that there are no different weights, right? But there are different length of that spring, right? That is noted by 4 millimeter and 8 millimeter, right? That means you will get 2 lines, two lines for theoretical value and 2 lines for experimental value, right? So in this experimental I think you will understand how to draw the graph, right? Every observation data are given in this video, so you can draw the graph for each type of governors, right? Then you will have 3 graphs, and for your lab report submission you have to draw the graphs, and with that with those 3 graphs you have to write down the introduction part and theory and this answer for the discussion questions, right? There are 3 discussion questions. You should answer for this discussion questions also, right? Thank you.